First, we're going to be talking about game analysis, like what you do to score points, what you want to be doing for a strategy, and then we'll be talking about choosing a strategy and what features the robot will need, designing the features, and building prototypes. So the first thing you want to do when building a robot is analyze the problem. So you want to be looking at the individual aspects of the game and figuring out what problems you want to be solving. You want to know the problem before you can fix it. Next is brainstorming. So what my team does when we brainstorm is we get together, we write down ideas, we brainstorm and talk about it, see what would be good ideas. Then the next step would be prototyping. And prototyping is when you're just building like a basic idea of what you want to be building in the future. So it's like a mini design pretty much. It's just for testing purposes, so you can test out different ideas that you have before it actually goes on the actual robot. Then you want to design it, which means you're taking your prototypes and you're making it ready for an actual on your robot design. Then fabrication, you want to build it and prepare it and make sure all the aspects of it are running properly mechanically. Then you want to redesign it, and refabrication, just go through those last two steps, making sure everything is to your satisfaction. And then game analysis here. When the field is released and you have the challenge, you want to go through all the aspects of the challenge so you can see what scoring things are, so you can see how do you score points. Like on the field there, like last year, we had the blocks and the cubes and everything. Like scoring, you could put them in buckets. You want to see what things are going to get you points on the challenge. And then what are possible penalties? You want to see what things might cause you penalties when you're going for the missions. How can you score points the fastest? You want to make a plan to see what points you can get the fastest. Like if there's something that's going to take a lot of time for not very many points, you might want to choose something else to do over that challenge. And what points can you get with a limited amount of time? Like in endgame, where you have a limited amount of time, you want to maximize the amount of points you can get for a set amount of time. And how can you be stopped from scoring or stop others? Like you want to see what kind of strategy you might pick when you're building your robot. You want to see like how might others stop you, and you want to see how you might be able to stop others from scoring also. And then I think Grant is going to come and talk about the other aspects of building a robot.
Thank you, Kohlton. So this is our very first robot that we built, and obviously we were rookies our first year. When the game challenge first came out, we decided that we wanted a robot with high mobility to allow us to maneuver around the field easily and quickly. It's kind of hard to see, but we really didn't spend a whole lot of time in the design and prototyping process. So that robot, that arm there is pretty much the only thing in that 18 by 18 square. So it was a lot bigger than it needed to be. It had a lot of dead space, and it also was quite heavy for only having a few things on it. Our second year, yep. Oh, there it is. No. I'm not very good at this. All right, so this was our robot from 2 years ago. We spent some time in the design and prototyping stages. We had very low budget, so as you can see, there's lots of Legos on there. And the robot was also very heavy because we used drawer slides instead of like 80/20. And there's lots of things that, because of our budget, we use those instead of the nicer and sleeker things. But With this challenge, we wanted to score in these high tubes. So for that year, there was a bunch of these pipes, and you had to get obstacles from the floor into the pipes to score. So we decided that was going to be our main thing. The problem was that we decided halfway through the year that we were going to ditch that idea and go for the end game scoring, which was even higher. And so we had to redesign a bunch of stuff and add a bunch of slides to get the extra height to get those extra points. And we ended up having a lot of problems because we hadn't tested our prototypes enough, and like lots of little things would get stuck or go wrong, and it made it very difficult to compete. And then, so this is this year's robot. We had these tracks here. When the game challenge was released, we noticed that it was pretty rough terrain compared to what FTC normally does. So we decided that our thing was going to be to not worry about the terrain. So we wanted to have as much mobility as possible so we could roll over blocks and not get stuck, and so we could climb the mountain. So this was the first iteration of that design. It has a pull-up arm here, and it has these tracks to allow it to go over stuff easily. The next iteration of that design is here. We added walls to help keep the tracks on and things like that, help protect us. Added things to help us get up the mountain easier. And then this is the final one. It's kind of hard to see there, but all put together. So with that robot, we chose our strategy, and then it was a lot easier to test stuff because that was the first year, this last year, that we had done league, thanks to the SOAR League. There hadn't been a league in our area before that. And the difference between leagues and whatever the other one is called, qualification matches, is that leagues you get to play a lot, and so you get to test stuff out more. So that was super helpful. But when the game challenge is first released, you want to start out by kind of choosing your strategy. After you've analyzed the game, you want to decide what role your robot's going to play. So do you want to be a defensive or aggressive robot? Do you want to be this really big, heavy, fast robot that's going to go in and kind of block goals and push people around? Do you want to be a support robot? Do you want to go for the goals that most people probably won't go for? Or do you want to be super good at one specific task? Let's see. Oh, and when you're choosing your strategy and like first designing stuff, you don't want to start right into like sketching stuff and prototyping stuff. You want to kind of take some time to think about it and choose where you're going. You also want to choose at the beginning of the year kind of where you want to end up at the end of the year. That'll help you to avoid some of those like last minute changes that cause you a lot of trouble. So you want to consider what features the robot needs. Like I was saying, you don't want to start right away with building stuff. You want to consider the tasks to accomplish, but not specific designs, at least not at first. So maybe the challenge is like this one, there's blocks here, looks like you can score on the floor. So you would want to say, okay, the challenge is we need to move blocks on the ground from point A to point B. Not, we need to design a specific piece and, have all these extra things. You also want to do lots of sketching, lots of SolidWorks and PTC Creo, as we heard about earlier. Those are great things because you can move stuff around, you can design stuff in high detail, 3D models, and it's really good for prototyping stuff. Then you can build prototypes, build small scale stuff at lower cost than building a full scale model. And then you want to test it. And you want to test it, usually until it breaks, at least if you have time to fix it before the tournament. And then modify it and put it back in your robot, test it again. And you also want to have lots of backups. That's something that really sucks at a competition. You go there and you have only designed one piece and it breaks. So you want to make sure your design, you can have backups. And then when you're designing stuff, you don't want to design up to the very last minute. You want to leave some time so you can practice with your new things that you've put on the robot, make sure that they're working, and just kind of leave it alone for the last little bit before competition. That way it helps so it's tested better. Also, throughout the design process, you want to be looking to the engineers in your community and stuff. So like I said, League was really helpful, the SOAR League. Also, there is a engineering group that is local here in Roseburg called Roseburg Forest Products, hashtag not sponsored. And they are really good. We've been able to show them our robot every year. We go and demonstrate it for them. And they've been super helpful because they have like a whole team of engineers there that, will say like, hey, we're having a ton of trouble getting this or that to work just right. And they'll say, hey, well, have you thought of this or that? Because they have way more experience than we do. And so they've been really helpful there. And they've also helped with like sponsorships and stuff and getting us connected with other engineers. So that's a huge resource, is your local engineering companies, and then, yeah, just other teams and stuff is great. The question is, do we take time to analyze how long it takes to score different points, and do we keep track of it in the engineering notebook? So that's a really important thing to do, is when you're looking at the tasks you want to accomplish, you need to think about exactly how long it's going to take to build it and complete it, how complicated it is, and then how long it's going to take to use that on the field. Because the matches are not super long, so you want to be able to score as many points as possible in a short amount of time. And then you want to also document it. So that's super important for FTC, as I'm sure most of you guys know, to put everything in the engineering notebook.
The question was that how long did we take to study the challenge before we started building? And I kind of thought that we studied and worked on it until we came up with a solid strategy that we wanted to go with.
And that took about, I think we had like 2 weeks or about 2 meetings where we just like looked at the challenge, researched stuff online and that type of thing, and just like hands off until we figured out something that was going to work. League is a huge help compared to the qualification system, because like you have, and it also kind of puts the pressure on you because you have usually 2 or 3 weeks, I think, between competitions is what we had. And so like, instead of going, we'll take care of that next meeting, it's like, okay, we only have so much time before the next one, and we've got to have this iteration of the robot done by then. So yeah, leagues are a huge help. Did knowing that we could compete in multiple league tournaments change the way we were building our robot? That was the question, right? Okay. Yeah, the league meets. I think it did a little bit. We still tried to have a running robot by the first league meet. But yeah, but it helped us with just, instead of like stressing out and cramming everything in to have it ready by one competition, we were able to test things well in a competition environment, which, though you can do that if you have a field, it's really hard to simulate all the different things that can go wrong on a competition day. So just having that was a lot of help. You can build it and test it, and you knew you would have a chance to test things out before, it was going to be a huge competition. The question was, in leagues, did you see another robot that had something that was really cool that you felt you needed to incorporate in your robot? I'm paraphrasing. But yeah, I would say so. You'd see like different designs and stuff, and then be like, oh, hey, that I hadn't thought about doing it that way, or programming help especially.
One thing I didn't notice, and we all noticed, is not only things that we thought we should do, is things that we shouldn't do. Yeah. We did see a lot of things that we knew, like we saw a lot of the tape measure design this last year, and we saw that that's probably not the most effective way to go about it after seeing it in tournaments. So we thought that was one of those things that we learned.